Dr. K. Parinivelu, Professor at the Center for Environmental Studies and Director of Center for Climate Change and Disaster Management, Anna University, Chennai. He obtained his PhD degree from Indian Institute of Technology, Madras, Chennai. He worked as project officer for a brief period at IIT Madras and moved on to the Center for Environmental Studies, Anna University in 1992. He was a visiting professor at Chungam National University, South Korea during 2007. He has been teaching courses on environmental chemistry, environmental pollution control, and instrumental methods of analysis since last 27 years. He has guided 75 students for ME and MSc, 4 MPhil, 2 MS, and 15 PhDs. He has published 135 papers in journals and 90 in conference and symposiums. He has received several awards in national and international levels.
Hello everyone, welcome to the course on Chemistry of the Environment. This course, Chemistry of the Environment or Environmental Chemistry, is useful for all the environmental science students as well as engineering students. If you look at environmental science, is a study of environment, its living and non-living components and the interaction of these components with one another. And chemistry, if you look at it, it can be defined as a science of matter. So, the environmental chemistry deals with the air we breathe, the water we drink and use it for other purposes, the soil that grows our food, and vital life substances and process covers everything. So, the interaction between these components, the chemicals present in this different segment of the environment also covers. And the main aim is to make a contribution to the improvement of the environmental quality. Individuals need to have some knowledge of environmental chemistry. That is the main aim of this course of Chemistry of the Environment. If you look at pollution, we manufacture massive amounts of chemical that is produced by modern industries, and these industries have given mankind an unprecedented standard of living and quality of life. At the same time, this has resulted in the price of environmental degradation. So, pollution refers to the release of harmful or objectionable chemical substances into the environment, most commonly as a result of our human activities. If you look at some of the examples of pollution, discharge of partially or untreated industrial as well as domestic effluent into freshwater bodies, and industrial operations like carbon dioxide and other gases released during the burning of fuels, all this is part of a pollution. At present, many environmental issues exist that have grown in size and complexity day by day, threatening the survival of mankind on earth and other living things. And some of the incidents of environmental issues that happened during our time, for example, London smog in 1952 killing about 4,000 people because of air pollution issues, the death of number of Japanese people in the Minamata Bay in the year 1960 due to fish contaminated with mercury because of the highly toxic monomethyl mercury species in this one discharge from electrochemical industry. And also throughout the globe, historical monuments and statues damaged by the acid rain water, mainly consisting of sulfur dioxide and oxygen nitrogen, including our India. The marble of Taj Mahal, popular Taj Mahal, is polluted. These are the certain examples throughout the globe how pollution damaged. So, it is very important to study the environmental chemistry, those who are involved in this field. And it is a scientific study of chemical and biochemical phenomena that occur in natural places. Okay. As per one of the very popular author on environmental chemistry, Stanley Manahan, he has defined environmental chemistry or chemistry of the environment subject as a study of sources, reactions, transport, effects and fact of these chemical species in the different components of the environment, that is namely air, soil, water, and the effect of human activities on this environmental segment. This is summarily he defined as environmental chemistry. And really, if you look at it, this subject not only chemistry, it involves all the discipline of science, that is multidisciplinary or interdisciplinary science, that include atmospheric, aquatic and soil chemistry, as well as heavily relying on analytical chemistry and being related to environmental and other areas of science in addition to the chemistry, like physics, life science, agriculture, material science, public health and sanitary engineering and other things also. So, it is not a purely chemistry, it involves all discipline of science. And to gain an understanding of the fundamental chemical processes that are central to range of environmental problems, and to utilize this knowledge in making critical evaluation of these environmental problems, this subject environmental chemistry is very, very important. That is, it will tell us what is happening to a chemical species in the environment, covering all subject knowledge of this. Ultimately, the persons involved in environmental protection or environmental conservation will be able to do their job precisely if they understand the chemistry behind all the environmental issues. If you look at what is the role of environmental chemist, normally expected to do the job. If you look at it, environmental chemist involved in environmental measurement and monitoring. Okay. One has to test what are the water quality or wastewater discharge quality, air pollution, what are the contamination of soil, everything is a job of environmental chemist. Okay. Once it is monitored, what are the state of environment with respect to water or air or soil pollution, then comes environmental regulations. Okay. Whether the wastewater discharge meets the required regulation norms or standards. Okay. The water used for drinking purpose, whether it meets all the drinking quality standard, everything as a part of the standard or regulations, this comes the environmental monitoring helps. After knowing this, actually environmental research is very, very important. Okay. And here again it is a multidisciplinary field, environmental research, not only for chemistry, it covers everything, biologists, engineers, all. Ultimately, the research is focused on two aspects. One is prevention, the other one is cleanup. Okay. So, we have to analyze why this environmental degradation is taking place, okay, and make effort in this direction to prevent environmental deterioration. Okay. That is very, very important. That is, prevention is better than cure, and in this way the 12 principles of green chemistry concept especially helps in this direction. The other one, after doing all this prevention, it is always sometime we will end up with some waste. So, it is a job of this environmental chemist and other related engineers or scientists is clean up the waste. Okay. Here again environmental chemists have a big role to play. So, if you look at it, all these things, it starts with analytical chemistry, monitoring the different type of pollutants and then compare with the regulations. If there is a need, they will go for a research, definitely it is one of the very, very important, and the research focused on prevention as well as cleanup, that is treatment. So, this is what the people who are familiar with the basic environmental chemistry, they can do the job in all this field. So, we are going to have a look at all this aspects in a series of lecture. We will start with first atmospheric chemistry, that is air pollution. We will start, and now we are going to discuss about atmospheric chemistry taking place in the atmosphere. And today I am planning to cover the importance of atmosphere, composition and major regions of atmosphere, and atmospheric chemical reaction taking place in the atmosphere, and ultimately one of the important air pollution episodes, namely photochemical smog, that we will discuss today. If you see the importance of atmosphere it helps us in many ways in the atmosphere. I have listed few things. Okay. Atmosphere plays a vital role in the survival of life in this planet by absorbing most of the harmful rays from the sun and stabilizes the earth temperature, preventing temperature extreme. This is one of the very important role played by atmosphere. It stabilizes the atmospheric temperature, preventing extreme cold, extreme hot is maintained by this atmosphere by stabilizing the harmful radiation, absorbing the harmful radiation. Next, if you look at it, the atmosphere provides very important chemical, that is namely carbon dioxide for the plant for photosynthesis aspects, through which whatever the green planet we see is because of this carbon dioxide comes from the atmosphere. And at the same time, very importantly, the oxygen we get for respiration is again comes from this plant materials. The carbon dioxide is taken up with the plant through photosynthesis, take up the carbon and releases the oxygen required for us. So, in the way the oxygen in the atmosphere also comes from atmosphere. Next, if you look at it, very important plant nutrient nitrogen. Okay. Nitrogen again comes from the atmosphere through bacteria fixing the atmospheric nitrogen, as well as if you go for synthetic chemical, the ammonia, that again manufactured by plants from atmosphere again. So, the very important nitrogen comes from atmosphere. Apart from this, the atmosphere also transport water. Its water cycling is happening in the through atmosphere, that is from ocean to land, thus acting as a condenser and a vast solar powered still. That is, whatever water vapor evaporates ultimately condensed comes as the form of rain. So, rain or water cycling is because of atmosphere, nitrogen fixing as well as nitrogen availability for various purposes comes from the atmosphere. Photosynthesis, plant to survive on this carbon dioxide present in the atmosphere, at the same time releasing the vital oxygen required for our living, and importantly it provides or stabilize the ambient condition, temperature extreme is prevented by absorbing the harmful radiation comes from the sun. So, these are the some of the very important role played by atmosphere. Next, if you see the components of our earth atmosphere, mainly it consists of the major constituents, nitrogen about 78% by volume and oxygen about 21%, plus other minor constituents like argon and other carbon monoxide etc. also present. This is a concentration of an unpolluted free air, okay, that is available in the ground level. This is minor trace constituents like neon, helium, methane, krypton, nitrous oxide, hydrogen, xenon, sulfur dioxide, ozone, nitrogen dioxide, ammonia, all these things presents at a very lower concentration or at a trace level, that is also naturally present, but the main components are nitrogen and oxygen. Now, due to pollution, there is a change in composition of these minor constituents, and we have lot of variation in this also. And look at carbon dioxide alone. Before the industrial revolution or about 100 years back, the concentration was about 250 ppm. Now, because of the various industrial activities, carbon dioxide level has risen about 410 ppm. Not only this, other toxic gases like sulfur dioxide, oxides and nitrogens also enormously increasing because of the various industrial activities. Or we can say, if you compare this fresh unpolluted air, now the air what we have, the composition is changed and minor constituent concentration is rising up with the industrial progress. Now, we will see how the atmosphere is classified, or the major regions of the atmosphere based on temperature prevailing as well as with the altitude, that is height, the atmosphere is divided into 4 regions, namely troposphere, stratosphere, mesosphere and thermosphere. These are the 4 regions of this atmosphere. Thermosphere lies just above the ground level. Up to 15 kilometers from the ground level is a troposphere, and we can see here that temperature was about the lower part of this earth, we have about 15 degrees Celsius. If we go up, the temperature goes on decreasing. At the top of this troposphere, it reaches about minus 56 degrees Celsius, and thereupon there is a constancy in temperature for some time, that is called normally tropopause, constancy in temperature. And if you look at it, the drop in temperature as we go up is about 6.5 degrees Celsius, 6.5 degrees Celsius per kilometer drop is happening. This is up to this place, tropopause. After tropopause, we have stratosphere. Here the temperature inversion is taking place. Okay. At the top of this troposphere, the prevailing temperature is minus 2 degrees Celsius. See this, from minus 56 it has increased to minus 2 degrees Celsius. So, there is a temperature inversion is taking place, that is negative lapse rate is converted into a positive one. That is, with the increasing altitude, temperature goes on increasing, and again top of the stratosphere it is minus 2 degrees, and for some time there will be a stratopause. Then again with the increasing altitude, temperature drops again further, and at the top of the mesosphere it is minus 92 degrees Celsius. And beyond this thermosphere, up to 500 kilometer, the temperature is very high. At the top of the thermosphere, the temperature may be about 1200 degrees Celsius. Okay. This region, you can see there's various chemical species. At the lower part of this troposphere, as I told you before, the concentration of nitrogen is about 78 and oxygen 21 plus other trace gases are present. In the stratosphere, an important chemical species is ozone, and because of the presence of ozone, the stratosphere is also referred as ozonosphere. The concentration in stratosphere is about 10 ppm, which is very important, and life saving chemical species as the ozone. It absorbs the harmful UV radiation and block it and prevent the UV rays reaching the earth atmosphere, the lower part of this one. And if you see the mesosphere here, because of this reaction with the sun closer, we have positively charged ionic species like O2 plus, etc. And the top of this, if you see, it's almost all ions, oxygen, nitrogen, whatever the chemical species present, everything is present as ions present because of the strong interaction with the solar radiation. And because of this reason, the thermosphere is also known as ionosphere. So, atmosphere is classified into 4 regions based on the height as well as prevailing temperature and chemical species. And this table summarizes the key characteristics of this troposphere up to 11 or 15 kilometer, temperature 15 degree to minus 56, and the important chemical species present in troposphere are nitrogen, oxygen, carbon dioxide and water. Stratosphere ranges from 11 to 50 kilometer, temperature, as I told you before, it is increasing from minus 56, at the top it is minus 2. Important chemical species in the stratosphere is ozone, very important. And mesosphere up to 85 kilometer, temperature drops up to minus 92 degrees Celsius, and the chemical species are O2 plus and NO plus. Thermosphere from 85 up to 500 kilometer, temperature again increases, reaches top up to 1200 degrees Celsius, and almost all the chemical species present in the thermosphere is present as a positively charged ionic species, O2 plus, O plus, NO plus, etc. And because of this reason, the thermosphere is also known as ionosphere. The atmosphere, various chemical species are present, okay. Especially in the context of pollution, so many gaseous pollutants and other chemical species are present. Let us have a look at what are the important chemical species. The inorganic oxides like carbon monoxide, carbon dioxide, nitrogen oxides, sulfur dioxides all present, including oxidants like ozone, hydrogen peroxide, hydroxyl radical, hydroperoxyl radical, NO3. All these things are inorganic compounds with the oxides as a species. At the same time, the atmosphere also has reductants, carbon monoxide, sulfur dioxide, hydrogen sulfide. These are all reducing substances, can react in a reducing way. Apart from this, we have organic components also present in the atmosphere, okay. And mostly these organics act as a kind of reductants. That is, in the unpolluted atmosphere, methane is a predominant organic chemical species, whereas we have variety of other alkanes and aryl compounds are also found in the atmosphere, and these are all indication of organic pollution comes from the industries. And also we have oxidized organic species because of the again pollution, carbonyl compounds, organic nitrates, photochemically active species, nitrate, formaldehyde, all these compounds leads to, we are going to discuss this, what is this photochemical smog little later. So, we have both organic and organic pollutants present in the atmosphere, especially in the lower atmosphere. In addition to this gaseous chemical species, we have acids like sulfuric acid, bases like ammonia, and interaction of these leads to formation of salts like ammonium bisulfate, and unstable reactive species, that is electronically excited NO2 hydroxyl radical species also present in the atmosphere. In addition to this, we have solid and liquid particles in atmosphere as a form of aerosols, okay, and cloud, and these play a very strong role in atmospheric chemistry as a source and sink for gas phase species. For example, if you have a solid particle like black carbon or soot particle, they have a very tremendous surface area, and because of this, all these organic compounds, these black carbon is able to capture, and all this toxic polyaromatic hydrocarbons is a part of this components on this solid particle. And also we have aqueous phase reactions also possible. The liquid droplets in the atmosphere, they also solubilize all this previous whatever the organic and inorganic compounds, they also present. So, in addition to gaseous species, these solid particle and liquid particles also present in the atmosphere, especially in the solid particle. For example, black carbon is the one which absorb light and provides heating effect, and also we have compounds like ammonium sulfate, they provide a cooling effect. So, depending on the nature of the particles, both cooling and heating is possible by the absorption of sunlight. Next, we will see what are the various chemical reaction taking place in the atmosphere that ultimately determine the chemical species present in the atmosphere. And one of the very important reaction in the atmosphere is formation of free radical species that we are going to discuss. Apart from this, reaction of atmospheric oxygen and nitrogen, that leads to variety of chemical reaction, that is also we are going to discuss now. And acid base reaction in the atmosphere also possible. As I told you before, for example, the bases like ammonia, if it is present, and reacts with the acids like sulfuric acid, leads to formation of salt. So, this is a kind of neutralization reaction or acid base reaction that is also happening in the atmosphere that leads to the formation of salt. So, acid base reaction, slightly acidic or basic substances, if they are present, for example, carbon dioxide, one of the slightly weak acid, that is also likely to react with water and come. And at the same time, we have very strong acids like oxides of nitrogen and sulfur oxides, that leads to the formation of acids like sulfuric acid and nitric acid because of the oxidation of oxides of nitrogen and sulfur dioxide, and they are also present, and these strong acids are responsible for the formation of acid rain that leads to deterioration of materials. And basic species are relatively less common compared to the acid substances in the atmosphere, and there are possibilities. Certain industries, if they liberate ammonia, and naturally also that is possible, that may give you some weak base, and especially particulate matters comes from the burning of coal and other things, releases calcium oxide and hydroxide and carbonate also from this alkali and alkaline earth metals. They release these oxides and hydroxide. They are normally basic in nature, and this is one of the issue, that is from fly ash that can react with acids like sulfuric acid or nitric acid as a result of the release of this. So, acid base reaction is one of the reaction taking place in the atmosphere, and for various chemical reaction to take place in the atmosphere, some things is required. Okay. Then only that will speed up the chemical reaction, and two constituents present in the atmosphere is very, very important. One is the radiant energy comes from the sun, predominantly the UV region, that is very, very important, because the radiant energy is very important to pump a very high level of energy into a single gas molecule to start a series of atmospheric chemical reaction, that is important. And the other one is hydroxyl radical species. Okay. So, this incoming solar radiation and hydroxyl radicals that bring out the variety of chemical reactions in the atmosphere, and these reactive intermediates act as a currency or money for the daytime atmospheric chemical phenomena taking place in the atmosphere. And especially NO3 radicals are important intermediate in nighttime atmospheric chemistry, whereas the daytime it is all photo driven reactions. So, the electronically excited molecule, that is a free radicals and ion consisting of electrically charged atoms or molecule fragments, these three relatively reactive and unstable species that are encountered in the atmosphere, they bring out variety of atmospheric chemical reaction, and they are also strongly involved in various chemical processes, these reactions. So, to summarize what we have seen now, we have discussed about the importance of atmosphere, how they protect as the harmful radiations and provides variety of life saving oxygen. Next, we have had a look at how the atmosphere region is classified and what are the important chemical species present in the atmosphere, and ultimately some of the various chemical species present in the atmosphere and the drive for the chemical reactions we have looked at it. And next we will see in details about the photochemical process, how variety of chemicals are getting transformed in the atmosphere. So, we see the remaining part of chemical reactions in the next lecture. Thank you.